unit that we're going to talk about is how clean is your water, and how would you know if your water is clean or not. So we're going to go do some testing today in the lab, and then obviously then out and about in the community. So the first thing that we're going to have to talk about is the environment around the water. So we have that word watershed. So here's the idea. So we have our nice little river, and all around the river is all sorts of different things. Like we have some mountains over here, and we have some trees, and then we got some houses, and all of these contribute to the water. So what's going on in all of these, plus our little clouds and the rain that's coming down, and any of our, like my little mountain there, it doesn't look very good, does it? Any of our glacier melting. So the idea is that everything that's coming from the sky, from the ground, is all going to our river. Then we have to figure out what the tests are. So the first one is turbidity. Turbidity is how clear something is. So if you have a cup of water and you can see the bottom, that means your turbidity is pretty good. But if it's full of dirt, it's not gonna look so good. So here's a couple pictures for you. You notice that this one, you can still see all of the 4 quadrants of the disc, and this one, nah, not so much. This is bad. Phosphates result in an algal bloom or algae bloom. Perhaps you heard of Lake Erie. They had a really bad problem with this, killed off a whole bunch of stuff. Looks really nasty. You've probably seen them before. They look something like this. And so notice it's green because it's doing a very specific process. What process are those algae things doing to turn it green? Oh, and by the way, what do you think the water quality of that is? Pretty good? No, it's pretty bad. So pH. So would you like to drink some acid, or perhaps a nice cold glass of base? No, of course not. You have a nice scale, and on one end of the scale you have 0, and on the other end of the scale you have 14. 7 is right in the middle. Okay, so over here are our acids, over here are our bases. If you have something that's an acid, then you are going to be in trouble because it's going to start dissolving your living creatures. Over here, you're going to start wiping them out because things can't function. This is the happy spot. A little bit above 7, a little bit below 7, but that's the neutral, and there are buffers that help keep us there. Nitrates are things that you put on your grass. So everyone likes to have green grass, right? But what happens when in your front yard, here's your front yard, and here's your sidewalk going up to the door, and then you ever see that little drain out in the street right here? It's got a little grate. And you go do your fertilizer and it rains. Guess what happens? All that fertilizer is going down into your drain, and you get a really gross thing. So like in China, where they don't really have any regulations, you get this, which is a lake, stream, river that these boys are swimming in, but it's overcome with plants. You can see there's hardly any fresh water. In fact, in the latest Olympics, they had to clean up all this algae so they could do their sailing competitions. Dissolved oxygen. A lot of times we think about fish breathing and the fact that they have gills, but there are a lot of other things that need oxygen, because if you don't have oxygen, you can't make energy for most of this stuff. So I got a little picture here for you. This is the Chesapeake Bay, and you'll notice that there are different colors, right? And you see anoxic and hypoxic here. Those, just think toxic, right? Look at the giant section of red and a lot of dark, right? So it's going from yellow, so closer to the ocean, the farther we get in, and then right in here you notice it's pretty bad. So something must be going on there in that watershed, that everything is going in here and killing our dissolved oxygen. You notice the size of the dot tells us how many living, right? That's life, and that is weight, how much we're finding, okay? Notice there's a nice black area there. We're finding nothing in the black area. But if we go down here, we see some quite large, and even up here we see some large. So there's a number here that's going to tell us whether it's good or bad. Then change in temperature, and this is, I just pulled this off of it. Temperature affects many physical, biological, and chemical characteristics. So if we change temperature, we're affecting a whole bunch of stuff. We want it to be a certain temperature. Whatever that temperature is, we don't want it changed. So what we're going to do is, here's our, let me get our pen here again. We got our river. We're going to take one sample here, and we're going to take another sample here. If there's a change, that means something's going on, and perhaps there's a pollution site dumping stuff in, right? Pollution, bad. Okay, it's dumping stuff in there, right? Notice that you have affecting it toxic waste, parasites, and diseases. So stuff really starts going bad. You see this actually out in Lake Erie, where the power plant is. Out in Lake Erie, here's our lake area, and here's our land, right? Here's our land. Okay, there is a power plant that gets cold water right here. As the water goes in, guess what? The temperature, it's hot right here. So the fish like to come over here and hang out, which lets our friendly fishermen go get them. Okay? So sometimes it's helpful for us, but the animal can get in terms of. Then conductivity. This is a new test. We did not do this in 8th grade. This is something new. We're going to check to see what is going on. Conductivity is actually electrical charge, right? So you have a positive and a negative, and certain things are going to go this way, and certain things are going to go this way, and we can check to see what would happen. We're also going to use some probes that are new and different from last year, so be prepared for something new.